We're looking at logarithmic functions. And the next chapter will go into some other aspects of logarithmic functions. But we're just looking at kind of the basic thing. A reminder, a logarithm asks a question. So this logarithm here asks the question, what base is 2 raised to get 32? So the answer to a logarithm is a question, is an exponent. So what power do we raise 2 to get 32? Well, 2 to the 5th power gives us 32. So the answer to this logarithm is 5. Logarithms are the inverse of exponential functions. You can write an exponential function as a logarithm and vice versa. So this is done by position. The nice thing is that b is the base in both the logarithm and the exponent, and b is written lower and smaller in the logarithm. The exponent in an exponential equation is the answer, let me use a different color, is the answer to a logarithmic question, and the answer to the exponential question, b raised to some power, well, that's the thing that is part of the question in a logarithmic statement. One thing I noticed about x, y, z, though, is they are going to try to trick you. They use totally different variables. So if we were to rewrite this in logarithmic, and they ask us to make this statement a equals b equals c equals. So if we were to write this in a logarithmic statement, I'm just going to write the logarithm. The base of my exponent is going to be the base of my log, and the answer to my exponential equation is going to be part of my logarithmic question. What power do I raise a to get c? And the exponent in my exponential equation is going to be the answer to my log question. Okay, so they will ask you to rearrange something real similar to this, and we're going to do that in below. It looks like in problem D. Okay, so I won't worry too much about that. Write the logarithms in exponent form and write the exponents in logarithmic form. So what power do we raise 5 to get 5? So our answer, what's inside the log is our answer to an exponential. The answer to my log is the exponent. All right, what power do, on B, log base 3 of 1/9, ask the question, what power do we raise 3 to get 1/9? And that's going to be -2. And now, you know, one thing you can do to write it in logarithmic form is to solve the equation. So if I'm going to solve C, if I want to rewrite it, one of the things I can do is apply a log base 10 to both sides. I'm applying a log base 10 because the base of my exponent is 10. Okay, if I apply a log base 10 to both sides, I get 10 to the 5th. That's just going to reduce to 5. Log base 10 of 100,000. So to take 10 to the 5th equals 100,000 and write it in log form, I'm going to get 5 equals log base 10 of 100,000. So you can either solve it or you can rearrange things. Okay, write z to the t equals s in the form log base a of b equals c. All right, so the base of my exponent is z. That's going to be the base of my log. The answer to my exponent question is s. That's what's inside my log. And the exponent in my exponential equation is the answer to my logarithmic equation. So I could have applied log base z to both sides. On the left side, I just get t. On the right side, I get log base z of s. So in the form they gave us, our base A is Z, what's inside the log is S, and C is the answer, that's T. So you'll enter those variables in XYZ software. Homework. All right, simplify. Log of, common log of 100. So if you just see there's no base given, that means my implied base is 10 with LOG. Now, log base 10 of 100 is asking the question, what power do we raise 10 to get 100? Well, that just simplifies to 2, because we raise 10 to the second power to get 100. This can be simplified even easier, because ln means log base E of E to the 5th. Those two, the log base E and the exponent base E, they cancel each other out, and I'm just left with 5. Another way to ask that question is, what power do we raise E to get E to the 5th? Well, that's 5. What power do we raise 3 to get 3? Well, that's just a 1. So those are fairly easy to simplify. And I'm going to stop here, and I'll continue on the next video.